This example comes out of section 10.2, products and quotients of functions. Again, this is from the word problem section, so rather than write out the big word problem, I just want to refer you to page 495, your turn. They talk about a pendulum, so hopefully you know what a pendulum is, kind of a mass hanging from a string, and it's swinging side to side. They tell us that the pendulum, its periodic motion, because it goes back and forth, back and forth, back and forth, can be described as 10 times cosine of 2t. I like this example because it ties some trig, which we haven't done for a few chapters, into it. And if you took a look at that function, what does that mean? They call p kind of the distance in centimeters from the center here, and this graph would go up and down, up and down, up and down. And so you could figure out its period. For example, we know that period equals 2 pi over b, so 2 pi over 2 equals pi. So approximately every 3 seconds, this pendulum does a full swing. They also give us a second function. It says q of t equals 0.95t, and what that decay function, and again I like this because it ties in, a much earlier chapter for us, that it's a decay function. It's got a base smaller than 1, so it's getting lower and lower and lower. They say the true nature of this pendulum is actually the product of those two things, p of t times q of t. In other words, 10 times cos of 2t times 0.95 to the exponent t. And if you put that into your calculator carefully, you'll see the most realistic picture of what this pendulum does, which is it starts off with an amplitude of 10, and it does have a period of pi, but that amplitude basically gets smaller and smaller and smaller as you go more and more swings, which if you swing any real-life pendulum that doesn't exist in the ideal frictionless physics world, but in the real world, a real pendulum will eventually slow down more and more and more and more and more. And so, if you graph this function, make sure you're in radians, set your window settings accordingly, you get a fairly accurate description of how the size of the pendulum swing gets smaller and smaller. Not necessarily a diploma-style question, I don't think, because it probably brings in too much stuff, but it is a good example of how you could relate chapter 10 to chapter 4-5 where the trig was, to chapter 7 where the exponential functions were, and have something that tied it all together. You will see some pretty good word problems towards the end of your exercises in 10.2.